Binu. I do the architecture part of the analytics part of the thing. So as Harry talked about the platform part, so apart from those, we saw fraud management, revenue assurance. We also have a services offering on top of our products or outside the products as well. So we have built a platform for that. I'll go into this what kind of. I'll not go into full details of the platform because that may not be relevant for all of you. So what I want to focus mostly on for a data scientist, how we are facilitating all these components, how we are facilitating this component so that data scientist life is much easier, much faster, and how we can derive value of the distributed architecture. That's going to be the focus of the discussion. For that, I just want to know how many of you actually work on some kind of a data analysis space or a data scientist where you are responsible for looking at the data, deriving insights out of it. I just want to know how many people are. I know that this is Spark Meetup, so mostly people are more towards the like big data side, data engineering side. So nobody is it? Okay. 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 Sir. Okay. Not me. Okay. So fine. I'll just quickly say why do we again why do we need a platform? Maybe because we are a developer, so it's inherent in nature that to develop something and keep it a platform. But that's not the only reason. If you look at just move on to the next one. If you look at a particular life cycle of a particular problem solving analysis, you start from capturing the data and you basically whatever different tools which you use to take the data into a system, whichever system you are having, and you parse, you do a lot of data pre-processing. That's the core of any kind of analytics project. Then you aggregate the data. So you aggregate the data, any kind of data, even if you take the unstructured data, you aggregate at various entity level, like the handle level or at a particular operator level, like that. You aggregate the data at different level, and the feature engineering. So what is feature engineering? Where you extract the features so that you can feed the data into a modeling aspects. So the feature engineering, then modeling. So that's where you use all these machine learning algorithms, statistics or the optimization algorithms which you are going to apply, and then you convert that into an analytics output and you communicate that to the end customer, whichever. For us, it's the operators, it's our end customers. So, but if you typically do any kind of, so if this is one of the report from the Forbes, whatever they surveyed it. So majority of the time, like 60 to 70% of the time goes into data collecting, cleaning the data, and making it ready. For that, we can at least start the feature engineering, not even feature engineering. Right? So that's the 60 to 75% of the time is going, which is a mundane work, which is very boring work. We can see like there were two surveys. One, where your time is going, what is your most boring work? The second most boring work is the work the time is going, because it's only repetitive. You just have to clean the data, because one time the data comes with null, you get age which are like 3000 like that. So what do you do with that? So you will have to do some intelligence over there. You have to pre-process it. If you don't pre-process it, those are going to be anomalies in your outlet. You can't show that. You can't say that, okay, you have 100 subscribers who are having 100 plus age. So it will come out as an insight, because if you apply anomaly detection, it will come out as an insight. It's not an insight. So business user, it is irrelevant. So you have to do that kind of cleanup, pre-processing of that. So that's the majority of the time it's consumed. So that is the one of the reasons which you wanted to go to the next. Yeah. So the reasons why we wanted to build a platform. It's not a fully automated platform, which is more not meant to the end users like the operators, like Harry, whatever the other platform, other products which we have. They are meant to the end customers so that they can configure, they can derive value out of it. This is a platform which is more supposed to be used by the data analyst, data scientist, who can derive value out of it. So what the advantages of which you are going to bring in the platform are basically automate the mundane work, the repeated work, so that you can focus more on the business. That's where you want to do more of modeling. You want to solve the problems, like whatever the customer is experiencing, what are different problems which way they want to solve, like they want to predict the churn, they want to find out which products, which rate plan is bringing in more profit. So different, that's various kind of problem. How do we solve that in a much better, much scalable manner? That's what you can focus on. And you can utilize the more of the resources, like if you automate something, you can give it for running overnight or whenever the resource has been utilized less. You can work on the data, whatever the comfortable time with that. Also, when you're having a platform, you can integrate various different tools. You don't have to only worry about one specific tool. You can integrate multiple tools and give a common interface to that, so that this data scientist or this data analyst can work on that interface, rather not worry about the complexities of the tools. So that is also an advantage by which you get a platform. So those are the advantages, like effort-wise, all those we get. But then what is the expectation? That is also all done one side of it. You also have a lot of expectations. As a data scientist, what they wanted to do, they wanted to have a workbench so that they can do exploratory data analysis. So what is exploratory data analysis? Where they take in the data, they look into that, and they do the feature engineering out of it. Basically, they identify what are the important aspects from the data, so that which I want to present to that, or which I can use it for modeling. So that is the workbench where they are going to do the exploratory data analysis, and they want to do advanced modeling. They want to do machine learning stuff, which are like decision trees, random forest, gradient boost, optimization algorithms. All those is what they want to do. Also, I think Hari has talked about the data scale. So we are getting billions of data in a day. So it doesn't make sense to us to work on a sample of the data. We wanted to work, even if you take a sample of the data, it is going to be too huge. So it is very important that we are able to work on a distributed environment. So that's one of the challenges with the existing system. So I'll talk about that, how we are managing that, how we are able to work, how we are able to do modeling and exploratory data analysis in a distributed manner. Okay, also another thing, again, what we have done over the last 5-10 years of our analysis of the data, we have found out that whatever the existing algorithm which is available out there, it works to an extent. But if you want to derive complete value out of it, we need to customize those algorithms. Either we have to take different approaches in the way we apply the algorithms, or we have to tweak the algorithm itself. So a lot of our libraries doesn't provide those tweaking capabilities. So we have to write our own algorithms. So that's what we have done. We'll touch upon what are some of the algorithms which we have changed it accordingly. And how you package this analytics. Okay, again, you would have heard of many tools. Even if you look at R, it is a tool which is more of a generalized capability. It provides you a lot of facilities. It provides you to do correlation. It provides you to do data imputation. It provides you to do modeling. But that all generalized approach. But they need to be stitched together. They need to be applied on a particular data types, on a particular relation based like that. So how are you able to, how we have approached that particular problem, not just providing a generalized system to the data scientist, rather to have a packaged analytics where they can directly apply and get the insights of the summarized output out of it. So we'll touch upon that. That will become a little more clear about that, how we packaging the analytics using this general purpose modeling tool. Okay, so going to the workbench. Okay, till now anything? Yeah, is it clear what I'm trying to say? So basically, what I'm trying to say is that all these big data components, how we are kind of customizing or stitching together so that it is easily used by a data scientist. That's the whole focus of it. Okay, so.
Sorry, a quick.
Yeah, please.
You talked about almost 80% on data cleansing.
Yeah.
Formatting.
Correct.
And 4% in the actual, let's say.
Roughly, yeah.
So for a data scientist, the use of the right model for data analytics is probably the most crucial function. There can be other, let's say, junior guys who will kind of do the cleansing and some automation and so on.
Could do that.
So for instance, when you talk of various algorithms, I mean, isn't the differentiating factor the quality of the data scientists with respect to the experimentation of new models?
Yes.
That they can use for new insights that are thrown up. So for instance, clustering. I mean, if you use the same standard algorithm, you're going to get very similar answers, or you're not going to get new insights.
Correct.
So what is that extent of experimentation that you do with new kind of, let's say, alternate models? Like you increase the dimensions of, So how much of that is really done in India?
Actually done in
India.
Okay.
I mean, there's a lot of stuff being done in, let's say,
Yeah.
this world.
Okay.
Let's say here, how much of that stuff is really done?
Okay. So if you look at it, I would say the cleansing part takes quite a bit of time. You can actually, as you were saying, maybe can be delegated to less skilled, like what we call it as data analyst, who can perform those kind of analysis. But even if you data scientist only look at the technique, that won't be correct, because what gives out you the best results only if you feed in the right kind of features. So the feature engineering is the most important aspect. That is where the data scientists need to really look at. That's what our experience of last 5-6 years is, that he has to build the right set of features. Now, when you have to build the right set of features, you need to understand the data more thoroughly. Now, he has to deal with the data. He has to do the exploratory data analysis to understand each and every field and what kind of values comes in, and in relation to the other field, how it performs. So unless he understands that data, he will not be able to make a value out of it. So even wherever it is in the world, what kind of problems you are doing, unless you are doing very over engineering of the features, like you go all out of all the features and you try to build out it, maybe you might hit some areas where it is good. But when you have to really show a business output, it is very important that you understand the data and you build the right features out of it. Unless you build the right set of features, you are not going to get a good insight out of it. That's how we have seen. I mean, we have some examples also. I won't be able to explain that in this particular session. We can take it out. But the feature engineering is the most important there. And in order to do the feature engineering, he has to understand the data. He has to understand the anomalies in the data. So he has to spend sufficient more time into this particular field. We can automate, that's what, we can only automate the known aspects of the data issues, like, okay, we are coming something about 300. Either we can discard those records, or we can put saying that, okay, anybody of that, we'll put it as 90 as the upper limit, or some kind of treatment we can do, that we can automate. But coming to the treatment also is something that a scientist has to know. If he doesn't know that all the values which is above something has been treated like this, his application of that into the model also will have an impact on that. So he has to understand that. Yeah. 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 So there are some guidelines, like you don't apply all the algorithms to all the problem statements. So some why such some requirements comes from the the end users, right? Assume that you want to identify churn, why some people are churning from my networks, leaving my network and going to other operator, right? So why that is happening? Now I can use a neural network and to find out and maybe get an accuracy up to say 60, 70 or 80% of accuracy. But what happens with the neural network is I don't have any explainability with that particular modeling. So I don't have any idea why particular subscriber is changing. All that I am capable of doing is, if the next guy comes in, I will be able to predict little more accurate, maybe with a different model. So although it is having a higher accuracy, it is useless, because why? It is very important that I should know that why he is churning, unless otherwise I can have a treatment to him to retain him in my network, right? So in those cases, I will not go for a neural network kind of an approach. I rather go with an approach where I have more explainability from the modeling aspect, like maybe a decision tree or a Bayesian network, where I can understand that on what aspects he is going to churn. So that comes from some based from the requirement point of view, or some cases because of the kind of cardinality of the value, kind of outliers in the data, or the kind of values you have. You normally tend to choose a particular algorithm or another algorithm. So we have tried out various different algorithms, neural networks, Bayesian networks, decision trees, random forest. Then we have picked up some of the best one working out there. And then also we found that some of them require a special treatment. So we have went ahead and customized in that manner so that it fits to our proper requirement. Does that answer? Okay. No, this kind of customizers are more of a general treatment again. Now we can, when we come to that slide, we will talk about that in more detail. It's more about how you say assume that I have a high cardinality feature out there. Now if I am doing a decision tree, okay, if high cardinality feature is going to come and impact my tree building, and it is going to have so many branches. Now I don't want to have that behavior. I don't want to have so many different branches with which results it's become too specific treatment which I may not be able to work. So I want to group them together. So the grouping logic will be again customizable, but I will have 2 or 3 strategies to group them. Maybe I'll group them based on assume that it's a something based on the property of the value. Like if it's a cell site, it's a column which I want to group them. I might group them where the cell sites are together based on a geo distance. Or I might group them together in the sense that how it is impacting the end. Like whoever is having more churn impacting, I will group those cell sites together. So those kind of strategies is what again is customizable to that level. Like that is what we develop our approach. Again, different scenarios, you might have to try out different algorithms or patterns, and we do that. Even though we customize the algorithms. Okay. So coming down to the workbench kind of workbench as a requirement from the data scientist. So in our domain, like in telecom, we have a lot of expertise who work on this SQL kind of environment. So our workbench requirement for us, it was heavily driven by an SQL. So we need to have a SQL supported workbench out there. So so that people can query. There are pointer queries, there are aggregations, there are partitioning queries, there are windowing queries, all those analytical queries which you want to support. That is one of the main requirements we have from the workbench, like the data industry is having from the workbench. Another important, see the workbench is what it's going to facilitate into the exploratory data analysis, because first time when you are provided with a problem statement, you don't know where to start. Like you start looking at the variables, you are looking at the values of the variables, you do the histograms, you do the correlations. So that's what you want to facilitate, right? So first you want to understand the data, so you fire a lot of queries, you see the distribution. Through queries it will be much more scalable in nature because we are dealing with a much bigger data. So then what another set of requirement is, you want to do a univariate analysis on a particular column, what kind of null values are there. So bivariate analysis, like how the relations are, all this multivariate analysis. Also you might want to build a modeling in the sense you want to see the anomaly detection, you want to do a box plot and find out which are the outliers. All those what is the modeling aspects you might want to do. So you need to have a support for one much more querying support where you can crunch a large amount of data and understand. Another one where we want to do some more statistical analysis. So when we are currently approaching this is one we wanted to, we are through Spark, we are doing Spark SQL, and one little challenge with the Spark SQL, what you are finding is that people need to know either Python or Scala so that they can get to that Spark SQL kind of a thing, which Python is also, we don't have that kind of a resource, so we normally work on the Hive. So we use Hive as to understand querying framework to query the entire big data as well. So Hive also works as a kind of a engine where we crunch the data and aggregate into the entity level. So whatever the daily usage data which we come from the external systems, we build various entities out of that. Like we build location-based profiling of that. We build subscriber-based. We build dealer-based. So various entities we build. On top of that, we do querying so that to understand what kind of behavior each entity is having. So another thing what we, so for not to support the univariate, bivariate, that kind of modeling, we were depending on Spark R, but Spark R, if you look at it, it is not really distributed. It gets the data into Spark R. It's only kind of a interfacing where you can get the distributed data into RAM so that you can further perform. So that is what we encountered with Sparkling H2O. So H2O is a library, it's a distributed in-memory machine learning algorithm. It's a fully in-memory algorithm. So they have built an interface to read the Spark data. So they have an interface for Spark RDD, and correspondingly they have developed the H2O data frame. So once you read the Spark RDD, you can convert to H2O data frame, and you can apply all these machine learning algorithms. So we are using a combination of both. Spark car is useful when you have a smaller data which you can load into your memory and you want to do quickly some processing. But if you want to do very complicated, a little more complicated machine learning algorithms, that's where we are using the sparkling water interfaces. Sparkling water is a very nice architecture, how it has been integrated with Spark. Maybe that's like a little bigger topic. Yeah, I think anyway, apart from that, we are using Python. That's okay, so this is where we talked about how we are customizing some of these algorithms. So this is decision tree and random forest. Basically, random forest is one of the major algorithm we use, and we have customized that pretty much to a very different level, so that we want to use that. So one of them, which I explained earlier, that when you have a categorical column which is having a very high cardinality, it results in a lot of branches of this thing, which is not very desirable. So we have different approaches. So identifying the top reason. So basically, again, I told you, right? So if you want to find out why people are churning or why a subscriber is, so if you predict that a subscriber is likely to call my call center, that's another problem, propensity to call. So that incurs a cost to the operator. If somebody is calling to the operator, he has to support that. So that is a cost. So they want to reduce that cost. So they want to find out why a particular guy is going to call me. If you find out, tell him that, okay, if a particular guy is going to call me with this probability, like 0.8 probability, next thing what he wanted to know, why he is going to call, what is the reason, like exact reason why he want to call and find out, so that I can do some counter, like send out an SMS or say that, okay, or maybe clarify the bill, something like that, so I can do a proactive measure to that. So in order to identify the top reason from the random forest structure, we have built on our own approaches so that we can find out, okay, this could be the reason, these and these could be the top reasons why he is likely to call it. So those can be bucketized and we take a separate strategy to how do we mitigate that. So that is another customization we have done. And also when we deal with fraud kind of scenario, labeling, right? So normally we label based on the percent. In a decision tree, we label each and every node based on the percentage of data goes into that particular node. But if you look at the fraud kind of scenario, which is much lesser in percentage, lesser than 1% could be. So if you do a regular way of tagging a node based on the percentages, it will result in, all of the nodes will result in kind of a non-fraud kind of a result. So we have a specific way of labeling the nodes so that some of the nodes are having sufficient number of fraudulent behavior in that particular listing. That is what another customization. We have done many more customization. I will just see through that. Another one we have recently done. One is that for the k-means clustering, we know that it uses Euclidean distance. So we are customized for that. We can build Euclidean distance on multiple columns and also a weighted average of the column. So some column I can give a much higher weightage and another column I can give a lower weightage. That kind of customization is as a configuration we are providing that. Also we wanted to, so this is one of the case we wanted to find out subscriber hotspots. So I want to find out, group those subscribers who are high usage. Also they are geographically located together, so that I can maybe set up a tower over there or maybe an additional D there or support mechanism over there. So we wanted to have geographical distance also as part of our clustering approach. So we have built in that Haversian is a distance which is it's a map distance kind of thing. So which we incorporated as part of our Euclidean distance along with Haversian. Another item which we are currently working, the social network analysis. See, the social network analysis, I think I already talked about the volume of data, right? So everybody, whoever makes a voice call to another person, so there is kind of a relation. So it's from me, another one call is going to that. That is a graph. So we want to build the graph because the graph gives you much more information about your behavior and whom you are connected to. Are you connected to a lot of people who are from the same network? Are you connected to a lot of people from the different networks? This also helps us to tell you about, are you likely to churn because you are connected to a lot of other network guy, and that network guy can influence you and to move on to that network because maybe the rate plans are cheaper, or we can move on, right? So it will give you the scenarios where a particular subscriber may likely to churn or may be likely to be acquired also. Now, if you find that a particular guy has been connected to a lot of my network guy, so I can always offer him, I can send out an offer to him saying that, okay, you seems to be connected, we have this kind of a plan, so why don't you migrate? That kind of acquisition scenarios also exist. So it is very important that it is very useful to understand the subscriber behavior if you build the social network. But the challenge with the social network is that the volume of the data. So if you have to build all my call to all other guys, then because in 100 million subscribers and each guy is connected to minimum 10 to not 10. In a day he's making 10 calls is what kind of estimation we are taking, right? So in a month data, he might have been connected to around 20 to 30 people roughly. So the network is so huge that there is no currently single tool which helps us to build the entire network and investigate on it. It's not only the building the network, we want to find out a lot of metrics on the network. So it's not easy because all these metrics which we compute on the social networks are very intensive. They need to compute on an iterative manner on all the nodes, then come again in iterative manner. So it's a big challenge. So there currently the way we are approaching is a slightly different manner. So it's also an approach, slightly different approach which you do. That's what I just want to focus here, saying that it's not only the algorithm tweaking, it's also the approach how we deal with it. So currently the way we are doing, we are building a communities, and within the communities we are finding out those metrics rather than finding out the metrics on the overall network. So different approaches. We also filter out some of those high degree nodes because it is, you could see some of the networks we are making 200 distinct people calling in say one day. So which is highly likely that a particular person is going to want 2,000 people. So it could be some kind of a call center or kind of a taxi service which gets called or calls others. So that kind of nodes also we are clearing it off. Those kind of approaches also you need to employ. We are employing that. That's the kind of customization we do on that, and we make this customization available as part of our platform.
What is the tool you use for SME?
Yeah.
What is the tool you use for SME?
Sorry.
Do you have a proprietary tool?
For the social network?
Yeah.
No, currently we don't have. So we don't have a distributed tool set for that. We are still exploring that. So we were looking at Spark, GraphX is there. Graph Frames is also there. We are also looking at Giraffe. But we have a little, we want to, one is that we want to handle huge volume. So currently the set of people who build these kind of social networks are like the biggies like Facebook, LinkedIn, those kind of have this kind of capability. They have proprietary algorithms to do that. But we don't have that kind of infrastructure to build such an algorithm. So we are depending on some of this graph processing algorithm which is available, which is Giraffe or GraphX. But we also have the requirement to have a graph storage. So it's not only the graph processing, we also want to have a graph storage so that we can interact. I talked about the SQL queries which you are doing on a regular database, right? Similar querying functionality is what we wanted on the graph structure also. So we need to a combination of a distributed graph storage and a distributed graph processing. There is no single tool here. So we have multitude of tools. There is tools like Neo4j is one, but it's a proprietary one. The community version doesn't have the multi-node distributed architecture. Only proprietary one have. But then again, we lose the customizability of what we wanted to do, right? So that's where we don't want to go to a proprietary tool. So we want to build our own. So we are looking at a combination of multiple tool set out here. So nothing has been confirmed. We are still exploring on that. There's a working progress. Okay. So yeah, see, this is what we are talking about. This is one of our, I would say, as part of our framework. This is one of our IP. Like it's a major innovation what we have done. See, instead of having means it's like having individual algorithm like correlation. This thing is not really sufficient enough to generate a insight which business requires. So we need to stitch multiple algorithms. We need to treat each variable in a different manner, and then only we can have the right output, right business output. We can have analytical output, some kind of correlation output, but that's not sufficient. So I'll just take an example. It's like, have you heard of Pareto principle? It's like, what is there in the economics? It's saying that 80% of the wealth coming from 20% of the people. Like that 80-20 rule, that's what we would have. So it is applicable in many scenarios, and we have, in our analysis, we also found that it is applicable in our domain. Some of the cases like you can see the bottom. The smartphone, which is 25% of the whole handsets, contribute to 95% of the data traffic, which is something which is very thin. So those kind of, there are different such insights which is hidden in the data which you want to unearth. Now there's no algorithm as such over there, right? There is no algorithm called 80-20 algorithm. So what we have come up with is our own approach. When we fed the data into this thing and we said that, okay, these are the feature columns, these are the columns which can be the cause, which are the columns which can be the metric, like the wealth kind of a column, then it automatically goes and applies the algorithm in a distributed manner and find out those kind of features which are related and the percentages along with that. So it will come out with all these kind of insights saying that 10% of customer related problems are causing categories are causing 83% of the complaints, like that. So that is a particular package. I'll just go to the next slide. So this is roughly the architecture, also our framework. Basically, we are capable of ingesting any kind of data. In this case, we would have taken some kind of a subscriber profile, which we built from the raw data. This signal hub is what I was talking about, the feature engineering, right? So based on our knowledge of last 5-10 years of knowledge in this industry, we have built large number of features which we can apply readily on any data. Not any data means different set of data. When you talk about subscriber on a churn problem statement, we have a lot of features which you already built on it. So that is what the signal hub is indicating over there. So the data which, when it comes in, we aggregate the data using Hive queries and put it on the profiles. So every day we are going to get the profiles, and we use a profile manager which we combine multiple days of web. Ideally, we look into kind of a 30 days or 60 days of profiles which we use. And on this profile data, every day when we get a new profiles, we apply our kind of package analytics, that one which we saw about pattern analysis, right, which sits over the like. So this pattern analysis, when it runs on this particular profiling information, we see it gives out those kind of insight which I was talking about. This is one of the package item over there. We have many more packaged analytics, which is kind of an IP, so I can expose many of them. So this particular algorithm uses scikit-learn, like the Python libraries. It uses Java. We have developed. We also the kind of k-means clustering and all we talked about, right? Those are all part of this particular packaged analytics. So which are extending the Spark data frames. Also, we write our own custom algorithms out there to extend and do it in a distributed manner. So that's the packaging analytics. So basically, what from our experience from the last 5 to 10 years, what we have found out that it is not the just having a machine learning toolkit like whether the SAS or R is not just sufficient. It won't solve your problem to the last extent which the business wanted it to be solved, right? So you need to take your business knowledge, your domain knowledge, feed it into that particular analytical algorithm, how you feed it in various different approaches or the tweaking of the algorithm, how you build the features, and then only you will be able to solve a particular business problem. This is kind of a recipe or a takeaway what we have learned from our data. That's pretty much. I guess. Let's go to the next slide. This is the last slide. So we use all these algorithms for the data ingestion, and Flume mostly, and I think Hive side they use the Kafka. Storage we are using. We just started using a HBase. We are heavily dependent on Hive. And for the modeling part, I talked about algorithms. Gephi is the tool which is used for social network analysis for a smaller data. So we also have a nice UI called Insights, Rock Insights UI, which is built on RAIDs, and we also use the D3 and PQ as an analysis arena. The mobile app is built on Ionic. That's just a platform on all the technologies which are using currently. I think that's pretty much